Alright, so we are working on Lab 2-1 Uniform Motion. By now, the goal, hopefully, is that you have all of your data filled out, including your displacement, interval velocity, and total displacement. And of course, by now, you also have your graphs. Hopefully, your first graph, which is total displacement versus time, looks somewhat similar to this. Make sure that you have yourself a title. Make sure that you've labeled your units. This is total displacement in centimeters. And make sure you've labeled your x-axis as time with seconds. A few things to notice about your graph is, of course, there seems to be a linear relationship on average overall between the total displacement and time. So as time increases, total displacement increases as well. We call that a direct relationship. And now that we have this graph completed, there are some questions that we can answer from our lab. If you take a look at the page after your first graph, there's a couple questions that are ready to be answered. First of all, it asks, can you calculate the slope of the line on this paper so your line of best fit slope? Remember, we talked about how slope in some graphs gives us extra value and extra information. So let's look at that. Now that you have your graph, let's actually calculate the slope. To find the slope, we're actually going to use 2 points on the line of best fit that you've drawn. Now remember, we don't want 2 points from data. We want 2 points that are actually on the brand new line. So right here is a good point, easy to read. And let's see, what's another convenient point to use? How about right here? Take that and take that. Remember, you need 2 points on a line to get the slope. This first dot right here are the data points. 0.36 seconds and 9 centimeters. This next data point is 0.84 seconds and it looks like 21 centimeters. Now that I have those data points, it's simple to find the slope, right? Which is just rise over run, or the change in y over change in x. So I'm going to do 21 minus 9, subtract the two y values, and divide that by 0.84 minus 0.36, which are the x values. And that should give me my slope. Up top is 12, and down low is 0.48. That ends up giving me a nice round answer of 25. Now remember, we're taking y over x. Y over x is centimeters over seconds for our units. So that means when you divide y over x, your answer for the slope ends up being centimeters per second. So that was the slope of my line. Make sure you can do the same for yours. So my slope for me ended up being 25 centimeters per second. When you look at this graph, what type of relationship does it have? You learned when one object goes up and the other variable goes up as well. That's a certain type of relationship that we learned about in class. Write down what kind of graph relationship that is. The next question is, what type of motion is this graph an example of? Well, think about the title of the lab and the fact that this car has been going at a fairly constant velocity. What type of motion do we call that? Write down that answer. For letter D, what quantity does the slope on the displacement versus time graph actually represent? That's where I tell you to look back at the actual units of your slope. If it's centimeters per second, think about what we've learned about that could be measured in centimeters per second. Perhaps that's the quantity that we're talking about. And by quantity, we don't mean a number. We mean what variable or idea have we learned about so far that could be measured in centimeters per second. So when we look at that graph, we actually extracted one more piece of information. Now you want to figure out your percent error from the graph in reality. And to do that, it says use ESS. That's just another way of the guess method, saying use your equation then use your substitute, and then actually solve it. So that's all that ESS means. Basically, show your work. In order to find the percent error, though, you need the accepted value and the experimental value. To find the accepted value, it says right here how to find it. Use the total displacement from your data table at 1 second, and t is the total time of travel. Plug into this equation. For your experimental value, use the slope that you just found from your graph. We know that the percent error equation is just your accepted minus experimental over accepted times 100%. So go ahead and find that. You obviously may want to pause this video throughout to do the problems and then keep moving. After you finished your displacement versus time graph, hopefully you also finished your average velocity versus time graph. Now, this is the interval velocity, meaning it's the velocities for each little second of time that you measured, and that is measured, of course, in centimeters per second. Make sure that you labeled not only your y but your x-axis with proper units and given it a title, and not only did you plot your data points, but that you drew in a line of best fit as well. Make sure you're using a ruler or a straight edge to get that job done. So before you move to the questions, make sure your graph is up to par, and check with your lab partners too. So hopefully